So the periodic trend. So of course the periodic table is arranged by increasing atomic number. So it goes from the lowest atomic number, of course, hydrogen, to, it just depends which periodic table you're taking a look at, could be as high as like 120 or 118. And so that's one of the things that we're going to want to take a look at. So there are some periodic trends that you're going to need to know. So one of the trends that we were just taking a look at is valence electrons. Now the valence electrons are the electrons in the outermost energy level, not the orbital, but the actual energy level. N equals 1, N equals 2, N equals 3. And so by looking at how many valence electrons, that's really easy to see from the group. So if you take a look and locate nitrogen, letter N, if you look at what group it's in, it is in group 5. So it has 5 valence electrons. There we go. 5 valence electrons. Now, if you locate Be, beryllium, if you locate it on its periodic table, it's on the left-hand side, right next to lithium. It is in group 2, and so it's going to have 2 valence electrons. Find krypton. Krypton, of course, is in group 8, the noble gases, and it's going to have 8 valence electrons. Of course, everything in that group of noble gases has 8 valence electrons, except for helium. Helium would be your exception because it only has electrons in its first energy level. All right. And so the periodic table can be used to determine the number of valence electrons. Another example would be sodium. So find sodium. See if you can figure out how many valence electrons it has. And titanium. I'll give you a second to do both of those. Now keep in mind, this is only for the elements in groups, in the A groups. It will not work for the transition metals, which are in the B groups. All right, another trend that you need to be aware of is atomic radius. Now, if we take a look at an atom, of course, this is kind of roughly what we've taken a look at an atom to look like. The nucleus in the middle and the electrons kind of outside of the nucleus. We now know they're a little bit more organized than previously thought. And so, as we're taking a look at that, if we measure from the nucleus to the outermost edge, this is the atomic, we need to get right from the nucleus. This is called the atomic radius, the distance from the center to the outermost edge. Of course, we can't really measure this very easily because these atoms are so tiny. As you go across the period, as you're going across, the number of your atomic numbers increasing, and your number of protons in your nucleus is increasing with one of the electrons. And so as you go across the period, the atoms actually get smaller, because there's more positive protons pulling on those electrons, squeezing the atom in smaller, making your radius decrease. But if you go down a group, the atoms actually get larger, and so your atomic radius increases. And so here's a picture so that you can kind of see that group trend. This is going down group 1. With hydrogen, lithium, sodium, potassium, rubidium. And as you're going down each energy level, keep in mind that that's really what's going on. In hydrogen, there's only one energy level. So if you take a look at the size of the atom, there it is. But lithium has electrons in the first energy level and the second energy level. So you can see our radius is larger. Whereas sodium has electrons in the first energy level, the second energy level, and the third energy level. So you can see we're getting larger and larger. Potassium, if you locate potassium, you can see potassium is in the fourth period. So it has electrons in the first three energy levels, and it's just started putting electrons in its fourth energy level. And so that's why the atoms get larger, the atomic radius gets larger as you go down a group, because we're adding another energy level. But as we're going across, if you take a look going across the period, if we're going across the third period where sodium, magnesium are, they're all have electrons in their third energy level. First energy level's full, second energy level's full, but as they add those electrons to that third energy level, the number of protons increases, and so the attraction between the positive protons in the nucleus and the negative electrons in that outermost energy level increase. And so our radius is getting smaller. Another one is ionization energy. Now, ionization energy is exactly what it sounds like. It's the amount of energy that is required to remove an electron and turn an atom into an ion. Now, of course, metals, if you remember my little thing about metals, metals tend to lose electrons anyway. They don't want them. So generally, metals have a very low ionization energy. So as you go across the period, ionization energy increases. And as you go down a group, it decreases. The reason that it decreases is because it's easier to remove those electrons when they're farther from the nucleus. And so remember, as you go down a group, your atom gets larger, and so it doesn't take a lot of energy to take one of those outermost electrons or valence electrons away. All right, so let's do a little bit of practice, right? So which one would be larger? O or S? So first locate O and S on your periodic table. I can see that O is in the second energy level, S is in the third energy level. And because it's in the third energy level, it's going to be larger. Let's look at the next one, Si and Cl. What do you think? Which one is larger? If you said Si, you're correct. And part of the reason is because Cl is further over to the right, so it is smaller. What about K and Kr? K and Kr. K, of course, is all the way to the left. Kr, krypton, all the way to the right. They're on opposite ends of the fourth period, so going across. And so K is going to be larger. All right, which one has the smaller ionization energy? It's going to take less energy to remove an electron. And the first one we have is again in the fourth period, Cr or Cu. And it's going to be easier to take an electron from Cr. It's over towards the left. How about F or I? F and I, of course, all the way to the right, or almost all the way to the right, right? And so iodine is lower down on the periodic table, so the electrons that it has in the outermost energy level, the valence electrons, it's going to be easier to take one from I than F. How about Sr or Te? So locate Sr and Te on your periodic table. So Sr, of course, all the way to the left, strontium. We looked at that earlier. Te, I'm struggling to find Te myself. All the way to the right on the same period. on the 5th period as SR. And so SR, of course, is more towards the left, so it's going to have lower ionization energy. And so once again, why does ionization energy increase as you go across a period? Because there's more protons in the nucleus pulling on the electrons more. Decreases going down a group because the outermost electrons are farther from the nucleus. They're not feeling that sort of nuclear attraction. And that's just where we wanted to get to today. I hope this helps you.